Hello again, I'm Samved Purohit and today we'll be dealing with Pascal's law, equation of continuity and Bernoulli's principle. So let's get on with Pascal's law quickly. So Pascal's law states that pressure applied to an enclosed fluid gets transmitted equally and undiminished in all directions inside the fluid. To explain that, let me consider a hydraulic lift. So, according to Pascal's law, the pressure P, the applied pressure over here, this arrow mark, is F1 divided by A1 over here, is transmitted throughout the liquid to the larger piston. This is the liquid, and it gets transmitted to this piston of area A2. So now, thus, the force of the large piston is given by F2 is equal to P into A2. The pressure P remains constant as P because it gets transmitted equally over here. Therefore, F2 is equal to F1 by A1 into A2. So now cross multiplying, we get F2 divided by F1 is equal to A2 divided by A1. Since A2 is greater than A1, therefore F2 is also greater than F1. This large force F2 can be used to lift or carry heavy objects like cars or something like that. So next, let's get on to equation of continuity. The equation of continuity states that the velocity of flow of a liquid at any section of the tube is inversely proportional to the area of cross section of the tube at that section. So now here, let A dash be the cross section, area of cross section, and V dash be the velocity at section 1 of the pipe. See, this is the section 1, this is A dash, the area over here, and V dash, the velocity of the fluid over here. Now let A double dash over here and be the area of cross section, and V double dash be the velocity at section 2 of the pipe. So the volume of the liquid that enters the tube is given by V is equal to A dash into V dash into T. So now we know that volume is equal to area of cross section into length. So now the length over here, as you studied in lower classes, velocity is equal to distance or length divided by time. So now the length becomes V into T. I've written that here by skipping steps, sorry for that. So V dash is A dash into V dash into T. So the volume that enters at section 2 is given by V double dash is equal to A double dash into V double dash into T. Again, the same principle with A double dash into V double dash into T. So we have assumed that the fluid is incompressible. Incompressible in the sense the volume at every place remains constant. V dash is equal to V dash double dash. So on equating, we can cancel T and T over time over here. So we get A dash into V dash is equal to A double dash into V double dash. So therefore we get A into V is equal to constant. So we can write it as area is inversely proportional to velocity. So we saw that over here. See the area of cross section of the tube at that section. Velocity is inversely proportional to the area of cross section of the tube at that section. You have seen this in your daily life, but you never realized it. Consider this to be your tap at home. So you observe that whenever you let water fall, your water comes down in area. This is because the water falls with an acceleration A or G, probably mostly, that is 9.8. Since there's an acceleration, the velocity of the water keeps on increasing. Since the velocity increases, the area decreases because of this relation. That is why it comes down like that. So now let's get on to Bernoulli's principle. It states that during the streamlined flow of an ideal fluid, the sum of kinetic energy per unit mass, potential energy per unit mass, and pressure energy per unit mass remains constant throughout the flow of the liquid. Now let's consider this to be a pipe over here, and the fluid coming like this. So pressure 1 is P1. Now the kinetic energy, that is that is half mv square potential energy, that is mgh, and pressure energy, that is m into p divided by rho. Rho is the density of the fluid. So now you can get this equation, since because of Bernoulli's principle you can equate the kinetic energy, sum of kinetic energy, potential energy and pressure energy at this place, and at this place. So you get V1 square by 2 plus GH1 plus P1 by rho is equal to V2 square by 2 plus GH2 plus P2 by rho. Since the mass is constant, it can be taken out common and cancelled. You get V square by 2 plus GH plus P by rho is equal to constant. This is called Bernoulli's principle. Here V is the velocity, G is the acceleration due to gravity, H is the height of water column, P is the pressure, and rho is the density. Thank you for watching. Enjoy physics.